Traditional fossil fuel equipment has always been way oversized. In our climate, we're sizing to the heating load because the heating load is always greater than the cooling load. These systems are inverter-driven variable capacity compressors, but they have a point where they can't go any lower.
So when you're into a little house and you have to put a big heat pump in, you have some asymmetries that need to be dealt with. How do we make this big heat pump that gets derated at a low temperature into a box that's built for a smaller heat pump?
You do what's called a manual J, heat loss, heat gain calculation. Part of that, you can either do that calculation with a blower door number, or you can guess at what the leakage is. We don't recommend anybody guess. We recommend they measure it with a blower door and feed that information into this software that calculates the heat loss, heat gain. A lot of times you need to do that as a room-by-room calculation. If you're going to zone the home, you can't do what's called a block load because now you don't know what your individual zones loads are, right? You have to do a room-by-room calculation. That takes longer, but it's necessary. So, you got to know in this room, am I putting a 6,000 BTU head or a 9,000 or a 12,000? Each room has to be calculated separate. So it's an engineering piece that can't be skipped.
You really got to have an upfront analysis done on those types of heat pump conversions.
If a system's performing well, it's going to continuously run at low speeds and then gradually ramp up. It's not this on-off, and oversized systems are going to be on-off and cycling, and that's not how they're designed to run. Going to shorten the life, you're not going to have good comfort out of it, and the energy bills are going to be horrible.